Okay, so this is how all the magic happened. So starting with the header file, we only really added the get temperature, humidity, and then obviously referenced here and over here. So everything else is the same in the file. The temperature, humidity, we have 6 bytes to read, and we begin the transmission on 0x44, which is the register for the SHT40. And then we write, bytes written is overwritten as 0, and we write each byte so that bytes written is updated to 6. And then we request from that address 6 bytes to read, create an array RX bytes populated with 6 entries for the 6 bytes, and then we go ahead and read into the array. So 0 and 1 on that array corresponds to temperature. I think 2 was a buffer, 3 and 4 had to do with relative humidity, and these are just conversions from, so we get better values. And then these 2 temperature and humidity pointers are what's returned to the main C++ file. So for the C++ file, the main file, we obviously added these basic SD and SCL pin, all the register addresses. And then we have button presses and Booleans for navigating between the screens. But going it down to the main functionality for this project, the main ones that we created were draw temperature screen. So we called get SHT40. Get SHT40 initializes the connection, and that gets the temperature and humidity from that basically library that we created. So we get those values. We just aesthetic things for that. And this at the top to name the page. This gets the Fahrenheit conversion of the Celsius value that's provided for the sensor. So this is where the temperature is drawn. We have Celsius and Fahrenheit. Even taps are Celsius, odd taps are Fahrenheit for the B button. And then this is where the T and basically all the centering is done. This has to do with the timestamp that's used for the actual relative temperature and humidity. So this refreshes every time that the screen refreshes or that a value is given. So draw the relative humidity, same thing with the temperature. We have basically just printing out and using that variable that we got from the I2C rewrite.cpp. And then this just a little note at the bottom for Fahrenheit Celsius conversion and the refresh rate. So the next big ones we had was dim screen and Prox LCD. So Prox LCD, we use the VCNL sensor. So what we did was initialize, you write to it, basically turn it on, and then you read the values that's given. So if it's greater than 200, put it to sleep. And if it's less than 200 or anything else, then it's woken up the display. And then dim screen, same process, turn it on, and then we gather data stored in ALS. And basically if the ambient light is greater than 55, set the voltage to this. We did 3 different stages because it just was a little bit smoother. When we were doing 2, it was jumping back and forth a little bit, and this seemed to fix the problem a little bit. So those are the main functions that we wrote to address the problems we had for the project. Just to go into the loop a little bit, we have the button functionality for navigating between screens. So we just have Booleans that are either configured true or false. And if they're true, draw the corresponding screen, zip code screen stuff. And then we have proximal LCD and dim screen called so that we can actually use that functionality in our program. So yeah, that is basically all the stuff that we added to project 1.
So this is Robbie and I's demo. So we'll go ahead, go into the main screen. We see that we have the city, the temperature, the high, the low, and the timestamp. If you want to convert from Fahrenheit to Celsius, you can go ahead and do that by pressing that first button. Once it refreshes, it'll do that. Then you could convert back to Fahrenheit if you want. And then with the press of button C, you could change the zip code, and then you'll get that value, that city, on the main screen. So going on into the local temperature and humidity screen, we get temperature and humidity values from the SHT-40, and we're getting local temperature and humidity, relative humidity. When we press the button B, we should be able to get a conversion from Fahrenheit to Celsius. And then along with that, we're getting the timestamp from the latest readings from the sensor. As I go up and press the sensor, it should raise the temperature and the humidity slowly. And then as I let go, it should also drop down accordingly. If you want to see that in Fahrenheit, we could go ahead do that. And then we can also demonstrate the VCNL sensor. So the VCNL sensor is the light and proximity sensor. As I bring my hand up close to it, it brings up the display brightness because there's less ambient light around it. And then when I actually just put my finger down on it, it completely turns down on it. It completely turns off because we don't have any proximity to the sensor. So that's the demo.